Hey everybody, welcome to the Unit 3 review packet for Algebra 1. We're talking about systems of equations and inequalities in this review packet. Let's get to the problems here. Number 1, graph the system of equations, then determine whether the system has no solution, one solution, or infinitely many solutions. If the system has one solution, we also need to name that solution. So for both of these, I think the easiest way to consistently tackle these problems is to use slope-intercept form. So let's get both of these into slope-intercept form, solving for y in both of those equations then. I'm going to call this one a, and I'll call this one b over there, but I'm going to add 3x to both sides, and then I'm going to divide by 4, and that gets me my equation in slope-intercept form for this one. This is 3/4 times x plus 2. So if I look at this, has a slope of 3/4 and a y-intercept of 2. That means I start there at 2 and I go up 3 and right 4 from there, or I could consider going down 3 and left 4. That's like -3 over -4. Negative divided by a negative is still positive. And so through those points I'm going to have a line. And then for this other one, I'll do that one in green. I'll call this line B. So trying to get y by itself in this one as well, I could subtract x and subtract 6 from both sides. The x here would cancel, and the 6 here would cancel. I'd be left with 2y equals -x minus 6. I also could have subtracted 2y from both sides and left the x and the 6 over here and solved it like that. That was another way to approach this one. But with this, we've got y equals -1/2. It's like an invisible 1 right there. So -1/2 x minus 3. So right here, here's your y-intercept, the -3 part. Start there. And then from there, down 1, right 2, if your slope is -1/2, going downhill as you move left to right. And where do they intersect? Right there is where they intersect. So if we graph that line, that's going to look like this, and the solution to this system of equations is where they cross. So right there, where they cross, is the solution, and that solution is at, it looks like -4, -1. And you could take those two values and plug them back into both equations. If you wanted to check your answer to make sure it was right, you could do that. So let's move on to number 2 from there. It says Pop's Cycle Shop sells bicycles and tricycles. The number of tricycles is 2 less than 2 times the number of bicycles. All the bicycles and tricycles together have a total of 26 wheels. How many bicycles are there? And note, you must solve the problem by using graphing, not by substitution or elimination. And it says to use x as the number of bicycles, y as the number of tricycles on this one. So if we have two equations here, we do have two equations here. In this equation for the first one, or in this problem for the first one, the first equation, we can take from this sentence right here. So the number of tricycles is 2 less than 2 times the number of bicycles. So that right there represents one equation, which I'll call A, and I'll put A down here. And all the bicycles and tricycles together, this other sentence, is another equation. I have a total of 26 wheels. I'm going to call this one B. And so if I come up with an equation for A, that would be number of tricycles represented by y is equal. So y equals 2 less than 2 times the number of bicycles. 2 less than would be -2, and 2 times the number of bicycles would be 2 times x right there. There's one equation. This is already in slope-intercept form. Pretty handy there. Equation B, or the second equation, all the bicycles and tricycles together have a total of 26 wheels. A bicycle, we know, has 2 wheels, so that would be 2 times the number of bicycles. And a tricycle has 3 wheels, so 3 times the number of tricycles. 2 times the number of bicycles, 3 times the number of tricycles would equal 26 if there's a total of 26 wheels. This one's already in slope-intercept form, so no need to do anything else. But this one we would want to solve for y. So subtract 2x, and that leaves you with this. Divide by 3, and you have y equals negative 2/3 x, and 26/3 would be the same as 8 2/3. So I could write it like that instead. If that was helpful to you, we could change that improper fraction to a mixed number, or even a decimal could help us graph that better. So it looks like this one has a slope of 2 but a y-intercept of negative 2. That means if I draw my axes in here, I'm going to want to have at least a little bit being negative. And I'll do my axes in black. Make that right on the line there. There we go. And if I want at least negative 2, then I'm going to go, why don't I go up 4 from there so I make sure I have enough room. And so those will be my axes there. There's my x-axis and my y-axis. I don't need to go negative in the x direction at all, just positive x values here. So I'm going to be graphing from there. This y-intercept is negative 2, so I'll put a point right there at negative 2, and then up to right 1. The slope is like 2 over 1 right there. So up to right 1, up to right 1, that pattern continues indefinitely. And then for the green one, 8 2/3 is the y-intercept. So 1, 2, 3, 4, 5, 6, 7, 8. There's 9, so it's a little closer to 9 than 8. And we're going down 2 and right 3. So go down 2, that's going to be a little lower than that grid line, and over 3. Same pattern continues indefinitely, down 2, over 3, down 2, over 3. Keep that going. And from there, then graph the lines connecting those dots. And see where they cross. So it looks like these two cross. That's a little off there, so let me just move that line just a skosh. That's better. And so where do they cross? Well, it looks like they cross right there. And what is that point? Where is that point? That particular point looks like is over 4 to the right and up 6. So that's 4, 6 right there. That means your solution or your answer to this question, it says how many bicycles are there. We know there would be, x was the number of bicycles, so over 4, that's 4 bicycles. And if you wanted to say how many tricycles there were, you could say that too. That's an easy question to answer. The question up here doesn't actually ask that, so you could leave that out and be just fine. But I'll write both of them down here. So we have 4 bicycles and 6 tricycles. You could plug those numbers back into the original equations and check your answer to see if you're right from there. Number 3, 4, 5, and 6, we're going to use substitution or elimination on these questions. Whatever looks easier, that's what I'm going to use. So on this first one, I notice y equals this and y also equals this. So if y equals 2 different things, I can set those 2 different things equal to each other. That's substitution right there. So negative 4x minus 2 equals negative 5x plus 14. And easiest way to solve that, I could add 5x to both sides and add 2 to both sides. Doing so will let the x's cancel there, and then let the 2's cancel there. I've got x equals 16 is what I'm left with. And then I can take that and plug it back in for x into either one of these equations to solve for y. I'll go with this one since it's more convenient, I think, because it's right there and it's not in the way. But both of these about the same difficulty, I think, to solve for x on, so I just picked one and went with it. This would be y equals, this would be negative 80 plus 14, and that would be y equals negative 66. Good idea to check your answers. I'm not going to do that here, at least writing it out, but take these values, plug them back in, and see if they actually work. This would be negative 64 minus 2, that's negative 66. This one would be negative 80 plus 14, that's also negative 66. So the check would work. Number 4, it looks like this one, if you have a positive and a negative 3y, that would be really easy to use elimination on instead. So this first one, I use substitution, but this one I'm going to use elimination. So I'm just rewriting the equations so that they're on top of each other, and then when I combine them together, the 3y's will cancel. I'm left with 3x equals 3. You can divide both sides by 3. X equals 1, and then take your pick. I'll pick this one and combine that together with the fact that x equals 1 to solve for y, and that should be y, or 1 plus 3y equals 7. If you subtract 1 from both sides and divide by 3, y equals 2. And if you're one of my students, I may have asked you to put things in coordinate form before. You could do that here. You could write that this one would be 16 comma negative 66, but if the directions don't say to do that, then you can just write it like you see there. So this one you could say 1 comma 2 in parentheses, that would also work. But again, just check out the directions and see what it says to do. Number 5, it looks like that one would be another good one to use elimination on, I would say. You could use substitution, solve for x or y here, or solve for x or y here, plug stuff into the other one and figure it out from there. But I think, at least in my opinion, elimination's a little easier on this one. We could decide what we want to multiply by here. It looks like 6 and 4, the lowest common multiple would be 12. So if I multiply this equation by 2 and then the bottom one by 3, this would make that negative 12y and make this positive 12y. It would get things to cancel out there. So if I change both of these equations, multiply everything by 2, that leaves me with this. Multiply everything by 3 here, that leaves me with this. If I combine those things together, I've got 12x. The 12y's will cancel. I've got 84 here. I can divide both sides by 12. That leaves me with x equals 7. And then I can take my pick. I'll pick the bottom one to find y. So 2 times 7 plus 4y equals 30. This would be 14 plus 4y equals 30. Subtract 14 from both sides and then divide by 4. There's your answer for y. Y equals 4. Again, you could put this into coordinate form. So 4 would be second, 7 would be first. If you were to graph these lines, they would cross at 7, 4. And finally, with this batch, number 6, it looks like substitution it could work, but elimination I think is a little easier, so I'll use that one. So I'm just going to rewrite the equations so that they're on top of each other here, and then figure out what to multiply by. So if I want to get the x's to cancel, I could multiply this by negative 3, and I could multiply this one by positive 5. Multiply everything by negative 3, that leaves you with negative 15x. Minus 6y equals 9, and that would be 15x on the bottom, positive 15x, plus 9y equals 45. That would leave me with 3y equals 54. I can divide everything by 3 there and get y equals 18. And then take your pick once again. Which equation do you want to use? Pick the one that looks easier to deal with. I'll go with the bottom one. And then for y, I want to replace that with 18. So I'd have 3x plus 54 equals 9. Subtract 54 from both sides. I'd leave you with this, and then divide by 3. So you'd have x equals negative 15. As a coordinate point, that would be negative 15 comma 18. And perhaps you noticed something that I did wrong here. If you catch that mistake, good for you. I just caught that mistake here. Checking my answers. I did not distribute the 5 to everything. I multiplied this one by 3 actually. So that's going to change some stuff here. That's okay. That's why we check our answers. That's why we make sure that we did it right. So this would be 15y instead. Everything else looked good, but that's going to change that. At least everything else in that equation looked good initially there, but that's going to change that to a 9, which is going to change that to a 6. So divide by 9, you got y equals 6. Plug in 6 right there. And that'll change that to 18. We're going to be subtracting 18. We've got some much different stuff here then. So that'd be negative 9 divided by 3 would be negative 3. So it looks like 6 is our y value, so that's going to come second, and x, our first value, would be negative 3 there. So you could rewrite this as negative 3 comma 6. Let's move on to 7 and 8. So now we're going to graph each system of inequalities. So on this first one, on number 7, I'll color code some things here. I'll go with blue, green, and red. For the blue line, x is greater than negative 3. When you have x by itself, go on the x-axis to whatever the number is there and think of that as a vertical line, because that's where x would always equal negative 3. However, this one should be a dashed line because you have just strictly greater than. You do not have or equal to. So we're going to have here, let me try to find my hidden line tool. There it is. And so I'm going to have a line like that right there. I'll deal with the shading in just a moment, but for y is greater than negative 1, go on the y-axis down to negative 1. This is where y always equals negative 1 right there, so we're going to have a line right there, but it's going to be dashed. And then we'll shade later on that one too. For the red one, the y-intercept is 2. This is in slope-intercept form, so it's going to cross the y-axis right there. And then slope is negative 3/4. Down 3, right 4. Down 3, right 4 would go off the graph. Up 3 and left 4 would be right there, though. This one is also a hidden line because it's not or equal to. So if we draw graph, it looks like that there. So this one, this red one, would be shaded this way because we're saying stuff that's less than, y is less than that. So think of that as a roof shade below the roof. With the green one there, we're shading above that line, and the blue one, we are shading above that line, but above, we don't really have above with a vertical line, so we shade to the right. Things that are bigger than negative 3, x value wise, would be to the right. Where do they all cross? That's what our solution is. They all cross in this little triangular section here. So that is our solution set. That's our feasible region, in other words. For this other one, for number 8, it looks like they are not in slope-intercept form to start. So I'll do the blue, green, and red thing again. But I'll solve these separately for y in each case. So this first one, 3x minus y greater than or equal to negative 3. You could subtract 3x. and then you can divide by -1 or just change all the signs. But if you do that, you divide by a negative, you have to flip the sign here. So this would be y is now less than or equal to 3x plus 3. Negative divided by negative makes a positive. If we graph that one, we go up 3, 1, 2, 3 for the y-intercept, and then the slope is like 3 over 1 right there. So up 3, right 1, or down 3, left 1 would also work. Down 3, left 1, down 3, left 1. This is going to be a solid line because you have the or equal to part in there. So I'll draw a solid line connecting those dots right there. For the green one, looks like I've got x plus y is less than or equal to 4. Subtract x, and you've got y by itself already. This is like an invisible 1 right there, so if you wanted to write that in, you could do that. And then that's like -1 over 1. So that's your slope, and that's your y-intercept. So start at 4 on that one, and then go down 1, right 1, down 1, right 1. That pattern continues. If you go the other direction, you're going to go up 1 and left 1, up 1, left 1. Another solid line because or equal to is a possibility. And so let's draw a solid line connecting those dots right there. I'll move that so it's a little more accurate there. There we go. And then finally the red one, that's 2x minus 3y less than or equal to 18. Solve that for y, subtract 2x. And divide by -3. If we divide by a negative, we have to flip the sign. This is 2/3 x minus 6. That's in slope-intercept form now. Go down to -6, and then go up to right 3. Up to right 3. And again, a solid line because or equal to is an option. Let me do that in red. There we go. And now let's take care of the shading. So when we shade this one, the red one, we're talking about stuff greater than or equal to. So shading above for the red one. For the green one, shading below, less than or equal to. So shading below that line. And for the blue one, that's y is less than. So we have another below the line. I'll go with that direction on there. Where do they all cross? What do they all have in common? That would be this section right here on this one. So make that part the darkest parts on your graph. Where they all cross is the feasible region, the solution set. Number 9 and 10. We're using either elimination or substitution to solve the problem, and you're encouraged to check your answers, but not required to do so here. So number 9 says Tyler had a summer lemonade stand where he sold small cups of lemonade for $1.25 and large cups for $2.50. And if Jared sold a total of 155 cups of lemonade and collected a total of $265, how many cups of each type did he sell? So let's determine our variables first of all. I think that using S for small cups and L for large cups would be a good idea. I'm going to use a cursive L so it doesn't look like a 1. And we're just saying how many cups of each type. So this would be the number of small cups, and this would be the number of large cups that he sold. And so it's $1.25 for large and $2.50, or I'm sorry, $1.25 for small and $2.50 for large, and the total is $265. So this all goes together right here to make one equation. I'll call this A. The other one comes from the fact that he sold a total of 155 cups. and I'll call that B. So equation A looks like this. You've got small cups were $1.25 each, so $1.25, 1.25 times a small plus 250 times a large is going to equal the total value there, 265. For the green one, you've got S plus L, the total number of cups sold would have to be 155. You could use elimination or substitution on this one. Personally, I feel like elimination might be a little tougher with these decimals. It wouldn't be that tough, but I'll use substitution because of that. So if I subtract L, I'd have S equals 155 minus L. That would be very easy to plug in now for S over here. So let's do that and see what happens. We've got 1.25 times 155 minus L plus 250L would equal 265. If you distribute that 1.25 to everything there, let's see what we get. So I'll take out my calculator for that. So 1.25 times 155 would be 193.75. So we have that minus 1.25 L plus 250L equals 265. Combine like terms. You're going to have, looks like positive 1.25 L if you put together negative 1.25 and 250. So that plus the 193.75 would equal 265. From there we could multiply, what am I saying? Multiply, I don't know. We could subtract 193.75, then leave us with this. And I'll need my calculator. I'll take my calculator again for that. So 265 minus 193.75 would be 71.25. And I could divide both sides by 1.25. And that leaves me with L, the large cups, would be 57. So I can take that then, plug it back in up here, and figure out what S is. So S is then going to equal 155 minus 57. That means S equals, it looks like, 98. And from there, if you wanted to check, you could. It said you're encouraged but not required to do so. I'll just let you know, for saving some time here on the video, that I have checked this answer and this answer into both original equations, and it worked out. So my answer in the end, though, I would want to use units with this. I would want to say that I have 57 large cups and 98 small cups. So from here, let's check out number 10. Alex is selling fruit for a school fundraiser. Customers can buy small boxes of oranges and large boxes of oranges. Faith sold 3 small boxes of oranges, 14 large boxes of oranges, for a total of $203. So I'm going to circle that. Mallory, on the other hand, has sold 13, looking at the 3, looking at the 11, combining those together, 11 small boxes and 11 large boxes for a total of 220. So there's my other equation. So I'll call this one A, and I'll call the green one B, and see what I've got here. So I would say that L would be a good letter for large, and S a good letter for small once again here. So I'm going to say that S, though, it says find the cost, so we want S to be the cost of a small box, and we want L to be the cost of a large box. I think those are the most sensible letters to use for our variables in this case. And so we would have 3 times number of small boxes plus 14 times the number of large boxes would have to equal 203. On this one, I'm going to use elimination because I think that's going to be easiest here. So for the other equation, it looks like Mallory 11 small, that's 11s, plus 11l, 11 large, is 220. To use elimination here, I think we should multiply. If we want to get rid of the s's, easiest way to do this would be to multiply by 11 and by -3, or by -11 and +3. But we want these two to be opposites of each other. So if we do that, multiply both by the numbers you see there, this whole thing distributed through for 11 would be 33s, and we'd have that plus 154l equals 2233. I've done the calculations on that already. And then this one, -33s minus 33l equals -660. If we combine those equations together now, the s's will cancel out. That's why we multiplied by those numbers. This would be 121 times l is 1573. If you divide both sides by 121, you'll have l equals 13. And then you can take your pick of what you want to plug in 13 for, the first or second equation. I'll go with the second one. I have 11s plus 11 times 13 equals 220. 11 times 13, that's 143. If you subtract 143 from both sides, you've got 11s equals 77. And divide by 11, that gives you s equals 7. So final answer on this one, you have, it's the cost, remember, of the small box and large box. The cost would be $7 for a small box then, and $13 for a large box of oranges. By checking your answer, you'll know whether for sure you've got it right or not on the test, but plug those back in. I'll just let you know, for saving some time once again on the video, that I have done that. I've already checked my answers in both equations, and it worked out in both equations. Let's move on to number 11 then. So write the inequalities for this system shown here. So it looks like, oh, I could call this A, and I could call this other line B, just to make it easy to talk about. So I'll go with B on that one and A on that line there. It looks like I'm going up one, right one. Here's the origin, and so I have an intercept of 1. And if I go up one and right one, my slope is also 1. So that would just be 1 over 1, which I don't have to write down. And I'm shading above on this one, so this would be greater than. It can be on the line. You have a solid line, so greater than or equal to, and that's it. Y is greater than or equal to x, which is like 1 over 1x plus 1. That is what represents that line that is shown there. We're shading above, so it has to be greater than or equal to that. For B, this is a horizontal line. That means it's y compared to something. It's a excuse me, a hidden line, and it's shaded below. So we would want to say y is less than, and not less than or equal to, because it's not a solid line. And if we shade below, we're shading below what is the line, what's the value right there. Y value is always 1 along that line. So we would say y is less than 1 for part B, or the other equation. Let's take a look at the last page then. We've got Zark. Zark buying some peanuts and cashews for a party. He can spend no more than $24. The peanuts cost $2 per pound, cashews cost $3 per pound. And it says X is the number of pounds of peanuts, Y is the number of pounds of cashews. And we need to write and graph the inequality. Excuse me. I've been talking too much today. I'm starting to lose my voice there. So write and graph the inequality. We would have peanuts cost £2, $2 per pound, cashews $3 per pound. Can't spend any more, no more than $24. So we're saying 2x plus 3y would have to be less than or equal to 24. And I'll use the x and y intercept method to graph this. I think that's a pretty easy way to go in this case. The x-intercept is where y equals 0. The y-intercept is where x equals 0. If you say that y equals 0, this part goes away. 2 times 12 makes that true, or it makes it equal at least. And then if you plug in 0 for x, this part goes away. 3 times 8 would be 24. So that's going to be your y-intercept. If we graph that, 12, 0 would be right here, and 0, 8 would be right there. And we can connect those with a straight line. And since it's not going to go in a negative direction for x or y, I'll just stop the line right there. This is going to be our feasible region in this case, is this area right here. You're not going to buy negative pounds of cashews or peanuts, so you've got to stay above the x-axis and to the right of the y-axis. And if we shade in our feasible region, it looks like that. So from there, we're trying to circle the points which actually are solutions. In other words, which of these points actually lies in the feasible region, the possible area. 2, 8 would be right here. That is outside the feasible region, so no. 4, 6, just outside the feasible region, but just outside still doesn't count. 8, 2, though, is just inside the feasible region. So this is the one that actually would be a possible solution to that. For the greatest number of pounds of peanuts that Zart can buy, peanuts was the x value. So if I go and find the biggest x value that's possible, it's right there. That would be 12 pounds of peanuts. And if x equals 6 pounds, here's x equals 6 pounds right here. What are all the possible values for y? Well, it'd be anything along that segment right there. So we're taking that and we're saying that 0 is less than or equal to y, which is less than or equal to 4. It's going from 0, you could buy 0 pounds of cashews, all the way up to 4 pounds of cashews and still stay under $24, or still stay $24 or less. And then finally numbers 16 and 17 and 18, doing these ones here. The owner of Fred's Fish Market orders cod and salmon. He wants to buy at least 50 pounds of fish, but cannot spend more than $300. Cod is $4 per pound. Salmon is $7 per pound. So if he wants to buy at least 50 pounds of fish, x is the number of pounds of cod, y is the number of pounds of salmon, we could say x plus y would have to be at least 50. That's greater than or equal to 50, in other words. And then the other inequality, can't spend more than $300, and cod is $4 a pound, salmon is $7 a pound. So if I take 4 times x, 4 times the pounds of cod, plus 7 times y, 7 times the pounds of salmon, that can't be any more than 300. It has to be less than or equal to 300 right there. So we could use slope-intercept form if we wanted to solve both of these for y and graph that way, but I'm thinking that x and y-intercept again will be an easier way to go on this one. So I'll do that for both of these. X-intercept is where y equals 0, y-intercept is where x equals 0. You plug in 0 for y, this part goes away, 50 equals 50. So your y-intercept would be the same thing, because if you cross that out, you still would have 50 being equal to 50. So those are our intercepts. To shade, that's where we think about the greater than or less than part, but our intercepts are going to be, for the blue one, at 50 and 50. We simply connect those with a straight line. And once again, we're not going to have any negative x values or negative y values. You're not going to have a negative cost or a negative pounds of salmon or cod that you're buying. So we're going to keep everything in this first quadrant here. The green one, your x-intercept there, still where y equals 0, y-intercept still where x equals 0. But if you plug in 0 for y, this part goes away. 4 times 75 would give you 300. So that's what's going to go in right there for the x-intercept. If you plug in 0 for x, this goes away. And then this would be 300 divided by 7 would give you the number that works right there. 300 divided by 7 ends up being 42 and 6/7. 42 and 6/7. So that would be your y-intercept. 42 and 6/7 would be about right there. And x-intercept 75 and 0 would be about right there. If we connect those with a straight line, rather than a crooked line, I guess, I don't know. Connect them with a straight line, connect them with a line. It looks like that. And here, if we solve for y, you'd subtract x, you'd have y is greater than. So we're talking about stuff that's shaded above the blue line. But then for y, if you subtracted 4x divided by 7, the sign would not flip. You'd have y is less than. So we're talking for the green one that we want to shade below for the green one. What do they have in common though? It's this little section, this little triangular section right there. That's our feasible region in this case. That's our potential solutions lying in that area right there. And so if we look at the final question here, number 18, circle the points, points which are solutions. 40, 15, let's plot that point. 40, 15 would be right there. Definitely in our feasible region. 50, 18 would be just outside the feasible region, be right about there. So that's a no-go on that one. 30, 20 would be, looks like right on that line, and it's solid because it can equal that. So this is actually a possibility. 55, 8. 55 would be right there. 8 would be right about there. Definitely in the region. So there's another possibility. 20, 35, that's going to be a little too high right there. It does not quite land in that feasible region. So it's A, C, and D that are going to work out there. So that does it for the review packet. Hopefully you found that helpful. I need to get some sleep at this point. Hopefully you will try this to the best of your ability. Again, if you need to practice it again, if you feel like you need to keep practicing, get ready for that test. Unit 3 test coming up, Algebra 1 students. Do the best you possibly can. Try to either solidify a good grade if you've got the grade that you like and want to keep that grade by doing well on the test, or improve that grade if it's not where you want it to be. Hope you have a great day. Again, go back, review, pause, rewind, refresh your memory on these things as needed. Do the best you can on the test. Have a great day. I'm going to go get some sleep now. See you later, guys. Bye-bye.